Ricky, you tried Nathan's bread yet? Fuck. Of course, as he doesn't have his headphones on. Awesome.
All right. Welcome, everybody. Seems like a good note to start on. All right. Sorry. Water down the wrong tube. All right. Looks like we probably have most people on here. So welcome to your recitation for discrete math. These will be weekly. And my name is Sophie. I will be the recitation instructor. I'm going to post a link in the chat here. Hopefully everybody who wants to join is joining, because they won't be able to see the link, and I'll just have to keep reposting it if new people join. So how this is going to work, and it's done pretty well so far. I think I like it. It's all experimental with this online thing. But anyway, we're going to be using Zoom for our communication piece, like audio and video. But I'm going to be using a Google Jamboard for our collaborative work. And it's basically a whiteboard, which is in the standard sort of Google Doc type format, where it's massively collaborative and you can just share with link sharing. And so I made this beforehand that we can do our work in. So if you want to stick that in your browser or on your tablet or phone or whatever, you can contribute real time as we talk through stuff. So let me know, anyone can just pipe up if you have any issues. Recitations, you may not have seen them before, since they're more of a European practice, but they're very similar to, say, a workshop or a lab, in just with math, basically, instead of science, where we won't be going over any new material, but it's basically your opportunity to get practice with the stuff we've gone over in lecture. Looks like new person joined, so I'm going to repost the link to the Jamboard. Oh yeah, so what we'll be doing here is it's purely participation based. Like, you won't be graded on correctness with exercises or anything like that, but I'll just take attendance with the report of the participant list, basically, on whoever was joining, and that'll purely be your grade for this thing. And we might sometimes do group work, so I'll probably experiment with breakout rooms at some point. But not today. Today we're just gonna get acquainted with the Jamboard platform and go over some things that we've been talking about with our first week of lectures. All right, so if you want to head on over to the link that I sent, we can get started. Oh, I also want to say that I will be holding office hours every week as well. Darren will be too. So on Mondays and Thursdays, 10 to 11 Eastern time, I'll just be on Zoom with a meeting open, and you can come and ask questions one-on-one if you want. That should have been emailed out. It's also in the syllabus, but if you need any other information, feel free to email me or just ask. All right, so on to the recitation material. So I'm going to go to the second slide here. You'll notice that you have the freedom to navigate as you see fit between different slides. So it's nice. It's much nicer than if I were just doing a screen share where you're stuck looking at whatever I've been looking at. And of course, you have complete editorial freedom here. So if you really wanted to, you could vandalize everything that I've drawn. But I'll ask that for the things that are necessary for our work that we do, please don't do that. You don't, Dan says you don't see anything. did you follow the link is my question.
Yeah, I followed the link. I clicked on the link and now it's just like it has discrete math R3 week 1 at the jamboard.google.com, and that's like all that's there.
Oh, interesting. Okay. I've experimented with a few different web browsers, and I had only a couple issues when I used Safari. So maybe if you're using Google Chrome, you'll have the best experience. Or not Google, well, it is Google, but whatever.
Yeah, I just reloaded it again. Like I clicked on the last link and that sent me there. And
okay, you're good then?
Yeah.
Okay, good. All right. So, just a little bit about me to give you an introduction, just to get to know me. Again, my name is Sophie. I am a PhD student at RIT, so I'm in my 4th year here. I'm in the math modeling program. So my research is related to deep learning for computer vision. So if you're ever interested in that, I could talk for a long time about it. It's a major interest of mine. I love doing it. I didn't go straight into grad school from my undergrad. I did a couple of years work in the defense industry. So I've worked at places like the Air Force Research Lab. I had a couple of years where I worked at Harris, which is here in Rochester, and I know they're very popular at the career fairs. And this past summer, I also worked at MITRE, which is, they do similar work to Harris, but they're in the Boston area. Outside of school, I am an avid trail runner, so I do a lot of training for long distance races, and I take my dog with me pretty much on every run that I do, so she's great, and also asleep in the room next to me. But yeah, that's just a little introduction to me, and I'll move on to slide 3 then. And this one's just blank because I want people to have a chance to play a little bit and get acquainted with the Jamboard tools. So you'll see that you have different pens and colors. The marker option is just a little bit thicker than the pen. And of course you can paint and highlight as well. There are also some assistive drawing tools, like you could doodle something and then it'll suggest, say, a square or a circle if that's what you're drawing, or like mountains or some, I don't know. Lots of different things, very powerful. Let's see. There's also an eraser, of course, and this little select, the select tool, which looks like an arrow on the toolbar, allows you to move things around that you've already drawn, or also draw a lasso around a bunch of drawings and then move the things that you've lassoed. And you could duplicate things and delete things. And then of course there's a laser pointer too, that you can use. And you can insert things like images, which is fun to do. So feel free to experiment with that for a minute or two, because today you will get to do some drawing. Well, very low level drawing, but you'll get to interact. Yeah, the purpose of this is to be interactive. So I wanted to make sure that nobody was having issues with this platform. Yeah, I see people figured out the text thing. Yeah, I like the laser pointer is cool. All right, no one's complaining that they're having problems, so this is good. This is good. All right, okay, well. Oh, nice. Harrison, New Jersey. Yeah, if you don't have you don't have a mouse. So this can work with, yeah, it's very hard to draw. I know, I did recitations last semester too, and all I had was a trackpad on my laptop, and it was very difficult to draw things, but I made do. It'll be slower and possible. Of course, if you have something like a phone or a tablet or a stylus even, that's the best experience, but I'm not gonna require anything of you that's gonna have you like know how to do perfect little drawings. So don't worry about that if all you have is a mouse or a trackpad. Like today, for instance, you'll just need to do some like small marks to vote on things because I have little voting exercises. Okay, so I'm going to move on to slide 4 then, since it seems like people are starting to get the hang of these tools and comfortable with it. Oh, the link for this, Camilla, you couldn't find the link for this recitation on my courses. So I did get asked about this before. Because this is a smaller group setting, only a quarter of the students in the whole like 100 plus person lecture are assigned to each recitation. So each of the recitations has its own My Courses shell that's separate from the main one that you'll get your lecture links for. So if you look at your list of courses, you should see one that says Math 190 R3 at the end of it. And that's where you'll find the links to these recitations. So hopefully, and if you are still having issues with that, you can email me, but that's where you should be able to find these. Let's see. Okay, so on to slide 4. What I'm going to do at the beginning of each of these is do a kind of overview of what we've talked about in lecture this week. Now, this was your first one, which means we kind of got the easy balls, the ones where like basic things about logic. So we talked about basic definitions like propositions, which are the basis of everything that you might talk about here. And then also we learned about De Morgan's laws, which is an example of it's like an analog for arithmetic rules, but for logical statements. So in particular, it's like a distribution law, right? So one of De Morgan's laws says, for instance, that if we have P and Q as statements, not quantity P and Q is the same as saying not P or not Q, right? And the other law just flips the and the or statement. So not quantity P or Q is the same as saying not P and not Q, right? So it's like a distribution law, right? And it just works for logical statements rather than arithmetic. So we'll use that a lot, which is why I put it here. Another thing that was mentioned in the textbook and in lecture, I believe, would be satisfiability. And this becomes, I think we only mention it now, but it's very, very important later on in one, like if you've ever heard of NP completeness, or the hardness of a computational problem, like the traveling salesman, satisfiability is central to that. So we'll talk a lot more about that later. All it means is that there is an assignment of values for a set of variables such that your entire statement is true. That means that the statement is satisfiable. We've also talked about predicates and quantifiers, and that is the upside down A for meaning for all, and then the backwards E for there exists a variable or a value of a variable. And then of course you can put them together to make a nested quantifier. So for all X, there exists Y such that X plus Y equals 0, for instance. We've also talked about the rules of inference, which are just broadly stated, how you can logically step from one statement to another, when you're allowed to say one thing and when you're not allowed to say another thing. Kind of vague, but we need to go over it a little bit. And then on to proofs, which are really central to this course. Proofs. There are different types of proofs, like existence proofs and uniqueness proofs. Oh, I should say, that reminds me, with uniqueness proofs, we've also seen, I know this was brought up on Monday in lecture, that whenever you see an exclamation point like this after the existence quantifier, that means there exists a unique value, one and exactly one value. I know exclamation point can mean a lot of things in a lot of different scenarios, but when you see it here after a backwards E, that's what it means. And it's only ever after a backwards E. Okay, and so we also talked about the different ways that you can approach a proof. So, for example, you can do an exhaustive proof covering all the cases, which is very common when you're programming something and you want to cover all the bases for solving a problem. You just go through all the possible cases that there are and then show something's true for each one, right? Now, you can also prove things directly. You can prove things by contraposition of the actual statement, and then you can use counterexamples too. Now, these aren't all the ways that you can approach a proof, but I've just listed the most common ones here. And in your homework, I've seen questions that ask, like, what's the way that you should prove this thing about integers? And I want to make it very clear that there are usually many different ways that you can prove something, but when it's asking what you should do in your homework, what it's actually asking is what's the easiest way to prove it. There's usually one way to go about something that is straightforward and simple, where even though a more roundabout way would also solve the problem. So don't get too angry if you can figure out how to solve something, but in a certain way, but then it tells you it's wrong. Okay, so I'm going to move on then to number 5. So here, let's do a practice exercise. One of the things that we have been doing a lot with in the material is this translation between the English language statements, which are flexible and there's lots of different ways to say things, right? Translating between that and symbolic representation of that statement. So I wanted to get practice with that here. And the reason we care about this is because when you see definitions, like the definition of a convergent sequence or the definition of what a graph is, it can be said in lots of different ways. But if you want to use that definition or theorem when you're showing some property, you need to be able to interpret it, right? And so symbols let you interpret things in a very, thank you for sending that link. It lets you interpret things in a standardized way. So let's do that for this problem. Again, for the person who just joined, I'm on slide 5. Nathan, welcome, Nathan. So on slide 5, I have 3 statements, right? And one is an A, a P, and an F. So A means that I will pay attention to a virtual seminar. P means that my phone is in another room, and F is my phone is turned off. So how would you say in symbols, I will pay attention to a virtual seminar only if my phone is in another room or it is turned off? So make your little vote in one of the boxes. And I'll give everybody a little bit of a chance to do that. So remember that the double-sided arrow means that it's a bidirectional statement. So it's like if you were to standardize the language, it'd be if and only if, right? And then these one-sided arrows are implications. So if blank, then blank is how you would standardize the statement, right? A lot of votes for the bidirectionality. Hippo. And a really good way to approach these types of problems is to try and restate them in that standard language, right? So if it's a one-sided implication, try and restate it as if blank, then blank, right? And that's not here. But it also doesn't say if and only if. So if you think it's the bidirectional one, you need to think of a way to restate it as an if and only if statement, right? So I think that's probably most people who have their marks down. So if anybody would like to defend what they think it is, I will ask. So who wants to make an argument for whatever they voted for?
I'll give it a shot.
All right.
So I voted for the first option, which was the leftmost option. And my reasoning for that was that the first thing I noticed in the statement, it says only if, so I took that to mean bidirectional. And then the second bit was if my phone is in another room or it is turned off. So that's an or statement, which is I can't remember what the symbol is called, but it looks like a union symbol in math. And then that's bidirectional to the virtual seminar A.
Okay. Well, bidirectionality, bidirectional statement says if and only if, not just only if, right? So you can actually, if you break down those words, if and only if, you have two sides to that, right? You have the if part and only if. And we only have one of those, right? We only have the only if side, which means that it must be a one-sided implication, actually. But the question is which one? And it looks like, so I guess what I'm saying is, let me give it a little different marker. It is not this. Because we only have one of those sides of the bidirectional statement. Although you're right, when you see only if, usually it's going to be an if and only if. It's kind of uncommon to see this, just the only if half of it. So let's think. Okay. Actually, I don't know. It's kind of evenly split, but it's the third one. I'll just say that. If you were to try and reorganize this. If you were trying to reorganize this sentence into the standard way, right? And that being if blank, then blank, how would you do that? Well, the necessary side of it, the thing that's necessary for the whole thing to be true would be this part. My phone is in another room or it is turned off. That's necessary for me to pay attention to a virtual seminar. So you might restate it as if my phone is in another room or it is turned off, then I will pay attention to a virtual seminar. Right? So that's how you would do this one. Yeah, I put it in here because it's kind of tricky, and it's because I've seen questions on the homework that use this like only if thing to try and trip you up. So, yeah. Does that make sense to everyone? Any other questions? Since it's a small group for the recitations compared to the lecture, you could always just like chime in. You don't have to raise your hand or anything. It seems like we're good though. So I'm going to go on to the next one. Let's go to slide. Oh, how would you say the second option? So the second option, A implies F or P, would be the converse, right? You'd say it, you would basically just get rid of the only. I will pay attention, or if I will, if I will pay attention to a virtual seminar, then my phone is in another room or it is turned off. That's how you would say the second one. So you'd have to, I guess, take this if and move it over here because the then belongs on the second half. But that's not what it's saying, right? It's saying that this part's the necessary part, not the first part, which is why we go with option 3. All right, so moving on to slide 6, I have another one. And again, it's kind of an English language part, although now we're not dealing with symbols. So we learned about 3 different types of statements, right? A proposition can either be a tautology, a contradiction, or a contingency. And the brute force way to figure out which one it is to make a truth table, which could potentially be giant, right? And then fill out your truth table. And of course, if it's all truths, if no matter what the assignments of truths and falses to your variables, then it's always true, that's a tautology, right? And then the opposite of that would be a contradiction if it's always false. And then if neither of those cases is true, then it's a contingency. So my question for you is, again, another tricky one because I'm not allowing you the space to write out an entire truth table. Can you figure out what this statement is? Is it a tautology, a contradiction, or a contingency? And you'll have to just kind of be a little bit intuitive. For instance, if you can find I'm not assuming that we know the answer to whether the moon is actually made of cheese or whether Elvis is actually alive or dead, by the way. That was a little bit confusing in the previous recitation that I did. But you can assign true false values to the moon being made of cheese, Elvis being alive, and unicorns having 5 legs, right? So, for instance, if you can find a way that assigning true false values to these 3 things, if you can find that to be true, then there's no way it can be a contradiction, right? Because that means that it's always false. We have unanimity in contingency, except for one person who says it's contradiction, maybe. In contingency, meaning that there's a way to make this statement false, but there's also a way to make it true. All right. Can someone tell me those 2 example cases then? How can you make this statement true, and how can you make this statement false? Because that would mean it's contingency. Anyone want to offer up what they're thinking?
I can.
Sure.
All right. So basically, you have the first part is if the moon is made of cheese and Elvis is alive. That's a conditional statement. In the case that either is if both of them are false, then it would actually turn out to be a true statement in that regard.
Mhm.
And with it being an or statement, the entire thing would just be true in the end. But if Elvis is not alive, or if Elvis is alive, and actually wait. It would actually be a tautology.
Nailed it. You nailed it. Yeah, good save there. So I'll interpret what you had, I think, come to a realization about as you were going. Yeah, so we want to show that it's a tautology, right? So let's just reason that there's no way for it to all be false, right? Okay, well, if there were a way for it to be false, how would that happen? Notice that there's 2 halves to this statement. They're both implications. The first one being, if the moon is made of cheese, then Elvis is alive. And the second one, they're connected by an or. The second implication is, if Elvis is alive, then unicorns have 5 legs. So since it's an or statement, we'd need both halves to be false in order to get a false overall statement, right? So let's start with the first one. In order for this to be false, we'd need the moon to be made of cheese being true. That needs to be true, right? And then Elvis alive being false, right? So we need Elvis is alive to be false. Just blanket. Now going on to the second one, we need Elvis is alive to be false, but that automatically makes this implication true, right? Because that's how implications work. They're true if the first half of them is false automatically. So there's no way for this whole thing to be false in any way. And so that's why we have a tautology as what it is. Now, of course, if you're ever really unsure about these, you can make a truth table and fill them out completely. But I just wanted to show that there are ways to reason through it without, using a big piece of paper. Any questions on that lingering? No? All right. Let's do another one. Actually, this one I'm just going to talk through. So on slide 7, I wanted to show you why it's relevant that we're doing these translations between English statements and symbolic statements. So let's take this definition of convergence sequences, which you're probably familiar with some course or another. And that a convergence sequence is defined, and we'll say Sn is a sequence. It's defined as having the fact that for any epsilon greater than 0, there is an n, a big N, such that the absolute value of Sn minus S is less than epsilon for little n greater than n. And I just stole this straight off of Wolfram World or Wikipedia, or one of those two. I think it was Wikipedia, actually. But it's not in that standardized language that we're used to. It doesn't have like if then, or it's organized in a perfectly clear way. So it's useful for us, like if we wanted to use this definition in a proof, it'd be useful for us to know exactly what it's saying, right? And the symbols can help us make sure that we know exactly what it's saying. All right. So the easy parts of this are where it does have the familiar language, like, oh, I see a for any. That seems obvious. So I think that, all right, let's go with that one. That's an easy one. For all epsilon. And now there is an n, capital N. Okay, that seems simple too. So we're gonna have a nested quantifier here. There exists big N. Okay, now we have this sort of non-standard language. The magnitude of Sn minus S is less than epsilon for n greater than n. All right, well, we can at least write down the first half of this. Oh yeah, epsilon greater than 0. Thank you for pointing that out. Let's start with that. I'm gonna put brackets here, such that epsilon greater than 0, and let's do something here, and something else, right? So any epsilon greater than 0. Okay, so we can at least write down this part. I'm going to suggestively put it over here. Oops. Sn minus S is less than epsilon in magnitude, right? Okay. Now, this for little n bigger than n, that's saying that we require the absolute value part is only true when little n is bigger than big N. So that sounds kind of like an implication to me. If little n is greater than big N, then the magnitude of Sn minus S is less than epsilon. Okay, so I think that we can write that as an implication. Oops, I can see here that I made a typo. There, that should be an and. Make that perfectly clear. And there we go. Now we have translated this into a symbolic version. Any questions on that? Doesn't look like it. Okay. I have one more for you. So on number 8, slide 8. Here's another voting one. We'll see if we can get the consensus on the correct one now. I took this one from one of the Learn Smart questions that was posted on Monday because I thought it was a good one. It points out that you can take quantifiers and don't mark them all. You can take quantifiers and unwrap them, as it were, so that you can get rid of them basically and cover all the cases. So we can do this reasonably without taking up too much space if our domain is small enough, right? So great. Let's just assume that our variable x has just binary domain. It can be either 0 or 1, and the domain of our other one, y, is 2, 4, or 7. So which is the correct representation of the statement, for all x, there exists y, such that q of xy is true? How can you write that without the quantifiers? And I've written them all out, but pointed out that the only thing that's changing between the different options are the placements of the ands and the ors. All right, seems like people are thinking. But I'm still gonna wait because I know there's 27 people in here. Well, 26, not counting me. Seem pretty evenly split so far. All right, here we go. Here we go. We're breaking the tie. Okay, awesome. I think people are getting it because the first one is correct. Does somebody want to tell me why? Because that's the really important part rather than following the herd. Who can argue why the first one's correct?
I'll give it a shot.
Go for it.
So wouldn't it be, because we know we have two values of x, we know that for every value of x there is one value, at least one value of y, which means that the center part would have to be an and from, if I'm reading this right, only one of those values of y can go with the x.
Mm-hmm.
Not sure how further to explain it, so.
Yeah, I mean, you're on the right track. So I think I can interpret what's going, you have it intuitively. I think I can help interpret what you're saying though. So for all x, q is true, right? So that means we have to have an and statement across the groupings of the different x values. And so here I've grouped the x values on this side and the other x values over here, and there has to be an and between them because it's a for all statement over the x values. But it's an existence statement on the y values. And that means that only one of them has to yield a true statement, right? So it's an or across all the possible y values since we only need one of them. And that's why across the group and give different y values, we have ors in between them. That makes sense, hopefully? Erase the other teams. Yeah, do it. One of the dangerous things about this is that you don't really see who is doing the edits unless people have avatars with their pictures, I think, that then you'd see, but I don't think people do. So it's all just like anonymous edits. So there's a lot of trust that goes into this usage of Jamboard. But I kind of like it. It's like daring. Okay. If there's no more questions on that problem, we can move on. So normally, normally I would collect, what's the word? Requests. I would collect requests from people in the entire week leading up to the next recitation on homework questions that you want to go over as a group. Because, like I was saying before, this course isn't structured so that your homework is strictly like you work alone and you only get one try and blah, blah, blah. No, we want you to succeed. So if you're stuck on something, just ask and we can go over it together in recitation if you want. And it doesn't have to be just homework problems either. If you want to go over something that was talked about in lecture, or you want extra practice with something like, say, induction proofs, you didn't feel like you quite got the hang of it from lecture, you can ask that too. Or technical problems relating to McGraw-Hill, if there are issues with that, or grading questions. This is your space to do that. I'm kind of a liaison between you and the professor, so you can feel free to ask anything. And since it's the first week, I don't think I got anybody who asked for particular questions to go over, but if you have something now, like feel free to chime in and we can work through it together as a group.
Do you have access to the last question? It was kind of
Homework?
screwy. I don't know if there was a typo or what. Yeah, on the
Yeah.
homework was the last question.
Let me open it up. Are you talking about homework 1 or 2?
1.
Okay. I'll open it up now. You said it's the last question, right?
Yeah, it was a big matching one, I believe.
Okay. I'm jumping to the last bit. 17? Next. Oh, come on. Here we go. Okay, I am actually going to share my screen now so that you can confirm. This is the one you were talking about.
Yeah.
Okay, so what's your question about it, if anything?
There are a couple that seemed, I wasn't sure if we were supposed to like just try and match all of them or if we were allowed to leave a couple. Apparently some people left a couple and it marked it correct. So I wasn't sure, but then also the one in the middle that's on the bottom half. Sorry, I can't count 1, 2, 3, 4, 5 up.
Is it this one? The exists not x p of x one?
Yeah.
Yeah. So to address your questions, yes, you are expected to leave some of them not matched. And in particular, this is one of them that you pointed out because the exists not x is a nonsensical way of writing things. At least I think so. So I do know that this one, that exists not x p of x, doesn't belong with any of these things. And so you're expected to leave it on the right-hand side. But yeah, so let's see. Working through this one. So P means x is perfect and F means x is your friend. And so the domain is all people, and then we have to drag these to their corresponding sentences. And of course, there can be some that go to 2 and some that go to nowhere. So no one, let's see, this one, not for all x f of x, and exists x not p of x. Anyone know where that one, how you would interpret that one is? Ideas? Oop. I think the bottom one gives it away because, oh, whoops. Actually, that's wrong because I got it mixed up with this one. The one below it was exactly the same, except there was an or statement between them, right? So not everybody's your friend is the saying not all x f of x. And then someone is not perfect means there exists somebody who is not P of X, perfect, right? I guess it's easier, I don't know. I don't know about a structured way to go through this, but we can start with the simple ones, I suppose. So for all X not P of X, well, everybody is not perfect, right?
Somebody wrote in chat also that the
Oh, yeah.
second one from the bottom, not everyone is perfect, I believe. The second from the top then.
Yes. Oh, good. Thank you. When I'm sharing a screen, I can't see the chat. That's frustrating. So I guess you'll have to speak up if you have a suggestion. Actually, I think that's a good way to go about this. If you see one where you think it matches, why don't you speak up? Because then I think it'll be a faster way to go through this rather than me going one at a time. And then we can get some input from other people.
I can try the next one.
Sure.
I think that should be no one is perfect too. Not
Which one should be no one is perfect?
The next, and so 1, 2, 3, 4th option. Yes, I believe so. Not everyone is perfect.
You're right. That's definitely true, right? So when you move a negation on the other side of an existence statement, that turns it into a for all statement, right? So these two that I've stacked here, one on top of the other, are equivalent. Nice. All right. Anyone else?
Does the last one go with the second from the bottom?
Everyone is your friend and is perfect. That's true. Right? Everyone meaning all X, and then friend and perfect. Nailed it.
Second from the top is that everyone is your friend and is perfect.
Yes. So that's taking advantage of the fact that you can distribute a for all statement across parentheses when you have an and within the parentheses. True. Nice. We definitely have more to match because there's at least one in each of these.
Is the bottom one go to all your friends are perfect?
That's true. So another way to say this is if a person is your friend, then they are perfect. Yeah. And that's true for all of your friends. So nice. Now I know this is nonsensical. So
The bottom one goes to at least one of your friends are perfect.
yep, true. At least one of is the same as saying there exists. And then we have an and. Is a friend and is perfect. Okay, I think that might be it, unless I'm missing something and someone can make an argument for placing this. But I don't think it can go anywhere. Because it would be not everyone is your friend and there is somebody who's not perfect. And I don't see that anywhere here. So let's check it. We'll see if I'm wrong. Ooh. Oh, I can't. I can't check my work because I didn't do the other problems in this section. Dang it. Come on. I guess I can't submit just, oh wait, submit. Yeah, I don't really care that I have incomplete questions, so. Because I'm not being graded. Let's go to 50. Correct, we did it, good job.
Awesome, thank you. Yeah, I was just confused because I wasn't sure if we were able to leave some out at the time. So I was
Right.
like trying to figure out how I could mash those two in, but they didn't fit. So I was confused.
Yeah, it doesn't really say that, does it? And the first time I was looking at this, I was confused too. But yes, I think in all the other problems, you can match everything, and that's why it's confusing.
Yeah, you can. I think all of the other ones. I didn't check all of my problems, but I'm pretty sure in all the other ones you can match.
Yeah.
All of them.
All right. So I think we can leave it there for today. I think this went well. I'm going to stick with Google Jamboard because it's fun and very amusing. So I hope everybody is doing okay with their first week of classes, and I will see you next week then.
Thank you.
Thank you. See ya.
Thank you. Bye-bye.